Alright, so to move on next, we have acids and bases, but specifically acids to name and write formulas for. The reason why we're doing this is because bases are actually just ionic compounds, so we already know how to name them. And acids, they write the formulas very similar to ionic compounds. So basically, we need to know today that an acid is a compound that contains hydrogen atoms and produces hydrogen ions when dissolved in water. So basically, if the hydrogen is in the compound as the first thing in a formula, then that tells us it's an acid. Okay. To write the formula, this is in your notes but not on the PowerPoint. To write the formula, still balance the charges to 0, like with ionic compounds. So when we have to name the acids, we have to do a little bit of a weird kind of thing. So we need to fill in this table. Okay. This table, the first left of it is super important, and this is what we're going to need for naming. The second side is an example side. So it all depends on what's with the cation. The cation is hydrogen, so the anion tells us what the name is going to be. So the first line is about if the anion is from the periodic table or if it's cyanide from our polyatomic ion list, because cyanide ends in ide. Okay? And then the bottom two lines are from the polyatomic ion sheet. Okay? So like nitrate, sulfate, phosphate, acetate, all of those. If it ends in an ite or an ate, it's from our polyatomic ion sheet. So the first line usually will just have two elements, H and something else, and then the second two lines will have H and multiple elements. Okay? So the reason why we depend on the anion is because the H in front tells us that the second word is always going to be acid. Okay? And then where the blanks are, that's where we're going to stick in like a root of the element's name. So like for chlorine, we're going to put chlor, or bromine, we would put brome, sort of thing, to fill in the space there. So let's go ahead and do these examples, and then we have one more page of examples, and we'll finish. So HCl. Notice how it has an H just like the other two lines have H's. So that H, all it does is it tells us that the second name is acid. Okay, so we're looking at what is after the H to tell us how to name it. And since Cl is just chlorine from the periodic table, so technically that would be chloride, then that's how we're going to name it. So where it says hydro blank ic, we're going to stick in the root chlor. So it's going to be called hydrochloric acid for HCl. And we use that a lot in chemistry. Next one, we have two H's, and that's okay. It's two H's just because the charges had to balance to 0. So the second word is going to be acid because I saw that H. Now I have to know what the name of SO3 is called. Well, SO3 is called sulfite. So we are going to drop the ite and add OUS. So a lot of people would think it's sulfus acid. But sulfur and phosphorus are the rule breakers here. Okay? For sulfur, we're going to put the whole word sulfur down. I did not come up with this rule. I'm just teaching it. So we're going to have SULFUR, and then we add the OUS. So sulfurous acid. If you would just put sulfus acid, I'm not going to count it wrong. I'll just write down the correct name after. Okay? And the last one, we have HNO3, so that H in front tells us the second word is going to be acid. Then now we need to know what the name of NO3 is, and that's nitrate. So this one's a normal one. So we're going to drop the 8 and add ic. So it's going to be called nitric acid for the name. Notice how only the first line has hydro in front. So the H doesn't tell you that you need to have hydro for anything. It's just that the second word is acid. So let's try our next 4 examples, and then we are finished with this section. So we'll do the first one and the third one before the second and fourth because it's doing what we just did. So we have HF for our first. The H tells us The second word is going to be acid. And now I need to know what that S is. Well, it's not a polyatomic ion. It's just fluorine or fluoride from the periodic table. So, since it's fluoride or fluorine, not a polyatomic ion, we're following the top line in our table, which tells us it's going to be called hydrofluoric acid. Okay? Next, let's get down to the H3PO4. There's only 3 H's because PO4 has a -3 charge. That doesn't matter right now, so we just have the second word is acid. Okay? Now PO4 is what we need to figure out the name of. Well, there's 2 elements in this formula, so that is a polyatomic ion, and PO4 is called phosphate. So this is a weird one like the sulfur, and so the 8 line tells us to drop the 8 and add IC. Well, we're going to, instead of having phosphoric acid, we're going to have phosphoric acid. So you almost keep the whole word phosphorus. So phosphoric acid for H3PO4. Okay, now from the name, let's write the formula. Okay, the word acid is telling us that we're going to start with an H+1. And that's it. Okay, because all acids start with H+1. And then we have, like for the first one, we have hypochlorous. Well, we have hypo, which kind of sounds like hydro, and then we have the OUS ending. Well, hypo is not hydro, so we can't do it the same way. The OUS is what's important here. Okay? So if we cross off the OUS and see on our table the OUS means that it's really the ite ending, then that means we're talking about hypochlorite. Hypochlorite is from your polyatomic ion list, and that's ClO -1. So now to finish off writing the formula, we just have to make sure the charge is balanced to 0, which in this case they do. So HClO is our final answer. The last thing we have is hydrobromic acid. So the acid word tells us that we're going to start with an H. Now we have hydrobromic. Hydro and ic, the combination, is on our acid list. So if we drop the hydro and the ic and we add IDE, because that's the line it's talking about, hydro, it's just bromide. That's from the periodic table, bromine. So bromine has a -1 charge, so the formula would be HBr. Our examples today did not have any that had to balance the charges to 0 by continually adding more ions or crossing the numbers, but you could still do that if you need to. So let's practice some naming and writing formulas of acids.